Now it's time for questions and answers. How do we determine which frame of reference to use? Well, this week we talked a little bit about you have sort of, say, a frame of reference here and then another frame of reference that might be moving. If this is 1 and this is 2, 1 might be moving with respect to 2. It could describe something's position or motion within one or within the other, so you'll always be told. It'll always say, give the velocity and the truck's frame of reference, something like that. If you have 3 objects in motion, will you also have 3 frames? Yes and no. You can have as many frames as you want. A frame of reference isn't always tied to an object. It can be, it doesn't have to be. So you could have the frame of reference of someone on the ground and all the objects are flying around in space. So you can have as many frames of reference as you want, but sure, you can definitely have 3 if you have 3 objects. Would a question tell us what frame they want the answer in, or should it be obvious? They will tell you. It shouldn't be obvious because they're all equivalent. Is there any way in which you can combine tangential and centripetal acceleration for an object and circular motion into one number, or would you keep them separate? So we also talked about tangential and centripetal acceleration. So if something's going around in a circle, we talked about how in uniform circular motion, you always have centripetal acceleration. If something is speeding up around the circle, then in addition to the velocity changing angle, it also changes magnitude, so you get a little bit of tangential acceleration. This one's much more common because uniform circular motion is more common than accelerating circular motion. But yeah, if you were asked what's the total acceleration, it would just be the vector sum of these two. It would look like that. But yeah, in most problems you tend to keep them separate unless you're asked to combine them. But you could combine them. What's the difference between the magnitude of A and AC in uniform circular motion? So I'm not sure exactly what this question means. So the vector centripetal acceleration in uniform motion always points in. So the magnitude of AC is just the magnitude without giving the direction. And we write it that way a lot of times because we have a formula for it, v squared over r, where v is the speed. And a lot of times we don't want to keep up with the direction because the direction is spinning around and changing, and that would require more complicated things than we want if we're just talking about the magnitude. So I forgot the question. The difference, yeah, so the difference is this is a vector with a direction, this is just the magnitude, the length of that vector. What is AR and how does it relate to AC and AT? Yes, so we talked a lot about these accelerations. So say you were in uniform circular motion, or no, you were in accelerating circular motion. Like, well, let's go here. You're in accelerating circular motion, okay? And you have, therefore, a tangential component and a centripetal component. It's really just which way do we define the unit vector. It's really all it is, the difference between AC and AR. They would have the same magnitude, just different directions. So in this case, say if AC, say is 4 meters per second squared, and you wanted to express it in terms of r hat, the radial unit vector, r hat points out. So it would be 4, it would be minus 4 r hat meters per second squared. Okay? And if you wanted to call it AC, you can imagine the AC unit vector pointing in. We'll call it c hat, pointing in, because that's center seeking, that's centripetal. This would be 4 c hat meters per second squared. The only difference between AC and AR is 1 points out from the circle, 1 points into the circle. And centripetal we usually associate with circular motion. Radial can be any arbitrary motion. You can think about the radial component. How is tangential acceleration calculated? This part, it's how much it speeds up. That would really depend on the problem. If you were told you're moving in a circle and you're moving faster and faster in the circle, you would think about how much does your speed going around the circle increase. If you were given an arbitrary curve and some particles following it in time, you would pick a point in time and you would calculate the part of the acceleration vector that is tangential to the curve, and that would be the tangential acceleration. So it would depend on the problem. Oh, an unbalanced force on an object causes acceleration, but what causes jerk? A force that changes in time causes jerk. In non-uniform circular motion, the acceleration, in quotes, is actually a vector sum of the centripetal and tangential accelerations, right? How do we decide which is along the x-axis and which is along the y-axis? So when you put something in centripetal and tangential acceleration, you're giving it a new set of axes. So it doesn't have to be x and y. You could think of it right here. And there's a centripetal direction, there's the radial direction, there's a tangential direction, and now it's different than x and y. And the reason you do that is when something's moving in a circle, it's constantly changing. These vectors are changing direction. So sometimes x and y aren't a convenient way to describe it because they're constant. Whereas you could think of this radial vector, it moves, unit vector moves around with the mass. Are vectors ever necessary after the vector unit? Let's see, I think you mean after the unit vector. Are vectors necessary after the unit vector? I'm not sure what that means. If you have just some number and you have a unit vector, that's all there is. Maybe you meant are units necessary? So usually you'd write it as a number with a vector hat to give it a direction, and then you'd write the unit, meters per second squared. Sometimes I get sloppy and put it in front of the unit vector, but it doesn't matter too much. A lot of questions this week. If we can do a problem intuitively, as I said, do we still have to do it with the relative vectors? No. So when I'm showing how to do problems, I describe, if you can just intuitively see all this, just get the answer. Or if you can't, write our position vector and go from there. So if you can do it intuitively, do it intuitively. But watch at the end, it might ask you to give an answer in terms of a vector. And then you will need to intuitively turn it into a vector. Star Wars or Star Trek? Star Wars, obviously. Is there an answer key to the discussion slide questions? Where can I find them? Look on the OwlSpace page under Resources. I believe they are posting answers to the discussion slides. What is the most interesting thing that you have ever learned in mechanics? Something interesting in mechanics? Probably, let's see, is the reason a top falls slowly. I would say that's the reason. We'll get into it later. Oops. Could the H, let's see, could the H equals V naught sine squared theta over 2G be used to find the angle and the components for the Harry Potter question? Oh, this is about a specific question. I don't really remember the details. The Harry Potter question, she threw something through a hoop. And we're figuring out whether it would go through the hoop or not. So yeah, I'd have to do the problem. Remember, office hours, that one. What's your favorite color? White. I don't have one. What does the subscript O mean? Like VO. Is it the same as VI? Thank you for making me feel old. Yes. So VO is the old-timey way to say V initial. It means not. V naught. Not means at 0, at time equals 0. Why? Because. And would you ever teach an art class? No, I am not at all qualified to teach an art class. Unless it was a class in drawing perfect circles on a blackboard, then maybe I'd just, give one lecture about that.